experiment, the insight is the understanding of real wastewater treatment. Learn how a treated wastewater treatment involves the multiple stage, which is the filtration, pH adjustment, equalization, and aeration. Realize the importance of each step. For example, filtration reduce suspended solid, and aeration help remove dissolved organic matter. Okay, next is a role of aeration. Realize how aeration, even manual, we use straw, help reduce bad smell and can reduce biological oxygen demand. Next is the understood the importance of oxygen for support aerobic bacteria.
So, one of the few challenges that we are facing while we do this project is, the first one, we are facing manual aeration limitation. It is because we use straw and we blow the air to that model into the waste. So blowing air using a straw was tiring and not constant, so it make the aeration inconsistent, while sometimes the bubbles didn't reach deep enough in the bottle to oxygenate well for the slush.
So the next challenges that we have to face, which is clogging of filter layers. Fine materials like cotton and sand sometimes clog easily, especially if the waste had too much oil or solid. Then, we may have had to redo or shake the bottle to restart the flow.
Lastly, I will be presenting our group reflection based on the challenges we faced and the results we observed during the wastewater treatment project. Throughout the filtration process, using a bottle filled with cotton, sand and rocks, we encountered several challenges. The most common issue was clogging, especially when treating water that contained a lot of fine particles and oil. Another issue was improper layering of the filtration materials, which caused the water to either pass too quickly or unevenly. We also found that sourcing clean materials like fine sand and cotton was difficult. These factors affected the consistency of our filtration results, especially since we used a homemade setup. To overcome these challenges, we applied several practical solutions. First, we treated the muddy water by allowing heavier particles to settle before filtration. We also ensured the filter was layered correctly, starting with large rocks at the top, followed by smaller stones, fine sand, and finally cotton at the bottom. Proper packing of the materials helped control the water flow and improved filtration efficiency. These adjustments allowed us to optimize the process despite the limitations of a simple setup. After completing all 4 treatment stages, which are equalization, pH adjustment, aeration, and filtration, we observed several positive outcomes. One key result was the improvement in pH. Initially, the wastewater was acidic with a pH around 5. After adding baking soda, we successfully neutralized it to a pH of 7, which is ideal for microbial activity. We also noticed a significant improvement in water clarity. The muddy water became much clearer after passing through the filtration layers. However, we observed a reduction in water volume, which is from 800 ml initially to 650 ml after treatment. This loss happened because some water was absorbed by the filter materials, while other amounts were lost due to evaporation, trapped solids, and spillage during transfer. Despite this, the overall process successfully demonstrated basic wastewater treatment on a small scale. Last but not least, these reflections helped us understand not only the technical aspects of wastewater treatment, but also the practical challenges of working with real pollutants using simple tools. It also taught us the importance of design, planning, and adaptability in achieving reliable treatment results.